On a recent episode of Our Ludicrous Future, in their Why Don't They Just section, the viewer asked this question.
It says, we know that light can generate small amounts of thrust because of the light sail missions. Why don't they just have small satellites to travel long distances propelled by a light source emitting from the back of them?
Now, this is a very, very good question here, and let's talk through it. I wasn't very satisfied with the answers here, but it's quite important. So in the last recording that I did, we talked about how you have to take into account the sunlight pressure for asteroids because any kind of light is pushing on you. But what if you're the one who's generating that light? Do you also push on it? Could you take a flashlight, like my cell phone light here, and go from point A to point B using it? The very short answer is yes, it would theoretically work. Okay, end of episode. No. We're going to dive way deeper into this. The light pressure that you're emitting does in fact push you in the opposite direction because light has momentum. That's the reason why solar sails work. For that same exact reason, when you're sending out light, it will also push you in that direction. So why don't we just have light drives? Well, how would you get that energy in the first place? And the best way to get that energy would be via some kind of solar power. Now, as you'll remember, the sunlight pressure is very, very minimal. It's even, a 1 meter square, you can barely even sense it. You have to have something rather huge to be able to sense this, like the size of a football field to push a couple of kilograms around. And even then, it'll barely actually do the trick. Pretty much everything that's sent into space is solar powered or has batteries that are stored charged on the ground, or is some kind of a radioactive thermal generator that uses the radioactive decay to produce the heat. So what you would be doing by this theoretical flashlight drive is you would be taking in the sunlight, converting it to electricity, then producing light with that and shooting it out the back. That's a huge, huge inefficiency curve when you could just simply reflect it and you'd get way, way more efficiency. Solar panels are only like 30-ish% effective. You're going to get actually more solar pressure from your solar panels than you would from your flashlight drive. So it just doesn't really cut it when you look down into the details about this. Now, this is actually something that spacecraft have to consider. When we were talking about asteroids, we talked about the Yarkovsky effect, where the asteroid is heated up on one side and then rotates and emits that heat out on the other side. And that will cause it to have a force along the direction of motion, which will change the position of it over some kind of a period of time. That emitted heat is a type of light, and this is one of those effects that has to be taken into account. Another very famous instance of this is the Pioneer anomaly. The Pioneer spacecraft that were sent flying past Jupiter and into the outer parts of the solar system had an unusual anomaly in their trajectory that we didn't quite understand. It was a very, very slight one. These spacecraft were something on the order of, I think it was a half AU, several millions of kilometers, tens of millions of kilometers even, or miles, different from where it should be. Now, when you're taking into account 40 years, just the smallest acceleration can take this into account. And they went and studied this data very, very carefully, and they realized that essentially the radioactive thermal generator was at one point in the orientation of the spacecraft, and the heat from that was causing a very gentle acceleration during the entire time. But they could actually track it to this one acceleration event, and that was able to produce the effect that really confused scientists and engineers for a number of years. This is something that absolutely can make a difference, but it's way too small to be practically used. The only instance where it could possibly be really used is if you had some kind of nuclear power, but it's really not even going to be that great then. Thank you guys so much for joining me. Let me know whatever questions or comments you guys have. Check out Our Ludicrous Future. It's an excellent podcast that a couple of smart guys will do. Thanks for everything, and until next time, keep on tracking. Take care, guys.